Now I want to take a look at another application of trigonometry, and that is the application which involves navigation and bearing. Now we recall when we're learning on positive angles and negative angles, we know that positive angles move from the positive x-axis and in the anti-clockwise direction, and this will call the positive angles. Similarly, for negative angles, it will move in the clockwise direction from the positive x-axis, and this is negative angles. Now I want to deal on navigation and bearing. And in navigation, we have 4 cardinal points. We have the north, we have the south, we have the east, likewise we have the west. And at the midpoint of each, we have the northeast, we have the southwest. Similarly, we have the southeast and also the northwest. So in what direction does bearing move? In what direction? How is it measured? Now it moves in a particular way, from the north to the south, to the east to the west. So therefore the navigation bearing are measured in degrees clockwise from the north. So it's measured in this direction. So this will be our 0 degrees, our 90 degrees, our 180 degrees, our 270 degrees, back to 360 degrees. So this is for bearing. However, remember in angles that will start from 0, go to 90, from 90 back to 180 to 270 and 360 degrees. This is for our angles. Our bearing is totally different. So the bearing, as we write again, from the north to the south, to the east to the west, starting from the north and with clockwise direction from 0 degrees to 90 degrees to 180 degrees to 270 degrees and down to 360 degrees. Now they are measured in 3 units, 3 digit numbers. Okay, they're measured in 3 digit numbers, so we can see a bearing of, let's say, 0.90. This is a bearing of 90 degrees. Okay, these are true bearings. This can also be, we can also write the true bearing of 45 degrees as 0.45 degrees, of 120 degrees as 120 degrees. These are called true bearings. Similarly, we can write it in form of compass bearing. So now let's take, for instance, we have 0 degrees coming to 180 degrees, passing through 90 degrees, and we want to write 45 degrees bearing. And remember, the 4 cardinal points involves north, south, east and west, and this, remember, is the northeast. So therefore the compass bearing in this case will be north 45 degrees east, and the true bearing in this case will be 0.145 degrees. Let's take another example. We have a bearing representing maybe 120 degrees from the north to the south, to the east to the west, and we understand that this direction will give us the northeast, likewise this would give us the southeast. So we can measure the angle here. The angle here will be, because if here is 90 degrees, then this way will be 30 degrees. So therefore we can write the compass bearing as north 30 degrees east and the true bearing as 1 as 120 degrees from the north. So we call this the compass bearing. and we call this 2 through bearing. But in most cases, when we are using solving trigonometric identities, or let's say trigonometric question involving bearing, we are always given the true bearing. So let's go for instance and now take an example. Let's begin with example 1. The question says a ship sails 12 kilometers due east and changes course and sails 12 kilometers due north. It should be then. It should be then changes course and sails 16 kilometers due north. Find 1, the displacement of the ship from the starting point, and 2, the bearing of the ship from the starting point. Now the first thing we have to know is the cardinal point. So from the north to the south to the east to the west, and the starting point is the north, 0 degrees. So let's begin. The first position of the ship is this. This is the starting position. Let's call it the starting position, SP. And then the ship sails 12 kilometers due east. So this is the east, north, south, east, and west. So it moved 12 kilometers due east. So from the east direction, the ship moves 12 kilometers. And then it stops. Whenever it stops, we have the 4 cardinal points again, representing north, south, east, and west. And thereafter, it then changes course and sails 16 kilometers due north. So from here, it sails 16 kilometers due north. So it stops again, and we call this distance 16 kilometers. When it stops, we'll flag it as north, south, east, and west. So this is the starting point. So we call this maybe the ending point, ED, EP. And then the question now is, what is the displacement of the ship? The displacement is always known as the shortest distance. So that means we are looking for this point, this distance. Let's call it X. Remember, the angle between north and west is 90 degrees. So this is represented as a right angle triangle. And the next thing is asking is the bearing of the ship from the starting point. So this is the final point, and we are asked to look for the bearing of the ship. So we are looking for the bearing from here to here. Let's call it angle theta. So to summarize it now, we have this. We are looking for X. We have 12 kilometers. We have 16 kilometers. And we are looking for the bearing theta. So the first thing to do now is to evaluate X. So using Pythagoras theorem, we understand that the hypotenuse squared is equal to the opposite squared. That's right, it's hypotenuse squared is equal to the opposite squared plus the adjacent squared. The hypotenuse in this case is x squared. The opposite is equals to 12. The adjacent, let's say, is 16. And moving on, we can now evaluate this. 12 squared will give us 144. 16 squared would give us 256. And the total is equals to 400. So we have that x squared is equals to 400. So if x squared is equals to 400, x is equals to the square root of 400, which is 20 kilometers. So this is the displacement. Now that we have the displacements, let us now look at how we can evaluate the angle or the bearing of the ship from the starting point. Now let's label this angle alpha. If we label it angle alpha, we can evaluate alpha. But before we evaluate alpha, we have to understand that theta plus alpha is equals to 90 degrees. So let's redraw the diagram here for ease of understanding. We have alpha, x, which is 20 kilometers, 12 kilometers, and then 16 kilometers. But then we are looking for theta, which is the bearing. So let's use, this is the opposite, adjacent, and hypotenuse. So whichever way we want to find the angle, we can do it. So let's use tan theta is equals to opposite over adjacent, but this thing it will be tan alpha because we are considering this angle is a right angle triangle. So tan alpha is equals to opposite over adjacent, which is 16 over 12, and 16 divided by 12 is equals to 1.33. Therefore alpha will be arctan 1.333, and this would be a representation of 53.13 degrees. Now we understand that the bearing starts reading from the north. That is why the bearing is this, from the north. Therefore, using our formula that theta is equals to theta plus alpha is equals to 90 degrees, we can evaluate theta, which is the bearing. Theta plus alpha is equals to 90 degrees. Therefore, theta is equals to 90 minus alpha, which is 90 minus 53.13 degrees. And this would give us 36.87 degrees. So the bearing is 36.87 degrees. Now, to write it in terms of true bearing, we can write it to give us 0.37 degrees because it's approximately 37 degrees. Now let's take another example. Question number 2. Now this is a very interesting question. Let's move it down to the next page, because it shows two different bearing. We have a bearing of 120 degrees, also have a bearing of 200 degrees, which we'll have to depict in a diagram. So the first question says a ship leaves a port. Let's say this is the starting position of the ship, north, south, east, down to west, and on a bearing of 120 degrees. What is the position of 120 degrees, we may ask? From here to here, 90 degrees, an additional 30 degrees, so we'll have 120 degrees. Okay, that's the bearing of 120 degrees. And with this bearing, it travels, let's change back to black, it travels 30 kilometers. So let's call this 30 kilometers. So we stop, we draw another cardinal point of north, south, east to west. So once it gets to 30 kilometers, it turns again, it turns to a bearing of 200 degrees. To a bearing of 200 degrees. How do we know 200 degrees? Remember, this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, so once it turns, that means we are moving from 0 degrees down to this point. Is at this center, just immediately after 180 degrees. So we call this angle, this bearing, starting from 0 to 100 degrees. Let's erase this. And it then travels another 50 kilometers. After that bearing of 120 degrees, of 200 degrees, it travels 50 kilometers. So we have another 50 kilometers here. So this is 50 kilometers. Likewise, we'll have north, south, east, and west. And the question now says find its distance from the port. So we are assuming this is the stopping point. Let's call it end point. And this is the starting point. So we are looking from the distance from the starting point to the end point, x. Now, to really understand this question, or to really be able to solve the question, we have to be able to use the bearings to get the angles in the triangle. So let's begin with this. We know that from here to here is 90 degrees, and definitely this place will be what? 30 degrees, because 90 plus 30 is equals to 120 degrees. So considering that, we are going to apply adjacent angles, and then this will give us 30 degrees. And similarly, if you apply this one, we will have 20 degrees here, and once we have 20 degrees to this point, the remaining angles at this point will be 70 degrees, because the sum of angles in the quadrant is 90 degrees. Definitely the sum angles at this point is 100 degrees. Now we can now draw the triangle. Now we have x, the angle here is 100 degrees, the distance 30 kilometers, 50 kilometers, and x. The question we are asked to look for is find the value of x. Now what does this remind us? This reminds us of maybe cosine law or sine law, and we know that in sine law we have a divided by angle of a is equals to b divided by angle of b, and is equals to c divided by angle of c. But in cosine law, this sine law works when we have two angles and one length, or maybe two lengths and one angle. But then in cosine law, we'll have c squared is equals to a squared plus b squared minus 2ab cos c. Now this is the same thing we have there. We have two lengths, which is cosine law, and one related angle. So we can easily evaluate the distance now. So we say x squared is equals to, just like we did in cosine law, 50 squared plus 30 squared minus 2 into 50 multiplied by 30 multiplied by cos 100 degrees. So with this now, we can simplify further. So we say 50 squared is equals to 2,500, 30 squared is 900, 2 multiplied by 50 multiplied by 30 is 3,000, and cos 100 stands for minus 0.1736, because we have simplified that 100 is in the second quadrant, and if you recall from our quadrant laws, in the second quadrant only sign is positive, okay, but cos is negative, so that's why we have negative here. So moving on, this gives us x squared is equals to 2,500 plus 900, 3,400, and 3,000 multiplied by minus 0.1736 will have it to give us plus 520.8. Then we will add it to 3,400. We will have x squared to be equals to 3,920.8, and the distance will be square root of this 3,920.8, which is equals to 62.62 kilometers. So the question we say is we should find its distance from the port. The distance from the port is 62.62 kilometers. Now we can see that there is no something too much new in bearing. All we just have to do understand that in bearing, the starting point of the angle is the north, which is 0 degrees, and it moves to 90 degrees, that's to the east, comes to the south at 180 degrees, goes to the west at 270 degrees, and comes back to the north at 360 degrees. Let's take another example on bearing.